Okay, going to start talking about descriptive statistics. We have about 3 videos or so. First one on central tendency, the next one on dispersion, maybe one more that provides, maybe an optional one, we'll see. What you're talking about here is I have the variables back up from introduction to data. And when we speak of central tendency, what we're talking about is sort of finding an ordinary value that is descriptive of the outcomes on a variable. Have all your variables here and a couple of more from that discussion earlier. You've heard of this since grade school, not grade school, 6th grade. Measures of central tendency, the 3 that we care about are the mean, the median, and the mode. And the importance of going over this in detail really relates to the discussions about levels of measurement, because one chooses to describe the ordinary value on a variable based on the level of measurement in large part, sometimes based on distribution, but usually the levels of measurement alone. So we've got a variety of levels of measurement over here from the beginning. Let's go through just as a quick reminder. OBS stands for observations. There are 10 of them in our data set, so n equals 1, I equals that observation, so on. Of course, we have our names. They're still all begin with J, same names. Rank, beforehand I had the qualitative category listed on the board. Now, I should write this down too. I only have the number. It's typically what we'll have in the data set or spreadsheet or whatever. Rank in school, number 1 is freshman, number 2 sophomore, number 3 junior, and number 4 senior. Then we have a test score over here, same as before. Added something which is operating system. In class when we work together, sad to say, for Windows users, this is generically true. This is OS X, the operating system for the Macintosh, is just flat out easier. And so it's sort of a gradation ordinal here, but I mean this to be a nominal level variable. So we can like categorize those. A nominal level variable where your operating system score is equal to 1 if you're using OS X, that is if you have a Macintosh. It's equal to 2 if you're using Windows. And I threw in a third here in a single observation. Let's say it's Unix, whatever. So 3, one of you is an uber compute person and you're just flat out using Unix. This is a nominal level, 3 category nominal level measure. The numbers mean nothing, remember by definition. This is what it calls a ratio level variable, the test score. If it had no, really measurement error doesn't relate to the levels of measurement, but if there was no measurement error at all from any perspective, mine as the test preparer, yours as the test taker, then we might want to call this not just a ratio level measure, but an absolute one, because it's really a proportion of things that you got correct. Proportions, remember, is probability, is a real scale. So anyway, we'll call it ratio level. Rank in school is obviously ordered, so you've been here longer if you're a senior than if you've been a junior, 4 to 3. Longer if you've been, if you're a junior than if you're a sophomore, 3 to 2, and so on. This is an ordinal level variable though, because the sort of interval level, nice illustration, the interval level variable underlies this one, is the hours earned, because we make a sort of cutoff mark. Once you've earned X number of hours, you move from freshman to sophomore status. Those of you in the classroom who are sophomores won't have the same number of hours. So that, therefore, it's an ordinal variable. It measures, we don't know the distance between the people within the category or even across it. So, name I'm not going to pay any attention to. It's called alphanumeric in the computer. Observation at the end, it's just an order. It's not anything. I've added two things here, age and gender. Gender is a binary, dichotomous variable, one that will say in the sample, not necessarily out in the real world. In the sample, in this case, we'll call it absolute. And age, another ratio level measure. Now, so choosing a measure of central tendency to get a sort of rough and ready definitions here. Choosing a measure of central tendency to categorize an ordinary value on a variable. This is going to depend critically on the level at which the variable is measured. The mean, I have a little notation up here you want to make a note of. Sample means we denoted almost universally as x bar, x with a bar on it. And it is, recall the summation sign means add everything up to the right. And recall that n on the top and I equals 1 on the bottom mean, and start with I equals 1 here, add all the way to n, all the ith observations to n, and then divide by n. It's a really, really easy thing. Don't let the notation get in the way of recognizing that the arithmetic mean, one simply adds up all the observations and divides by the total. The median. The median is the midpoint on a scale. It's the point, more formally, that you should write down. It's the point that divides half of the observations on the high side from the half of the observations on the low side. Sometimes the median is actually observed and sometimes it's not. So you've got, it's actually observed if you've got like one observation or two observations as sitting on the midpoint, but if you've got, let's say, 13, the spot between 13 and 14, just to make up numbers, 14 would lie on the high side, 13 on the low side, then you would call them the median 13.5. More simply, the midpoint, more formally, the point that divides half of the observations from low to high. The mode is simply the category on a variable that contains the most observations. It's the most frequently observed of the possible outcomes on a variable, and it is especially appropriate to start in on, it's especially appropriate for nominal level data. Especially. Not uniformly, but especially. Especially appropriate for nominal level data because none of the other measures of central tendency have any meaning at all with respect to nominal level measures. That is, you should never even think of reporting or describing the median or the mean of a nominal level measure, because remember that the numbers are just stand-ins for a quality that's unordered quite naturally. In this case, it's your operating system, OS X, Windows, or Unix, and they certainly don't have natural numeric meanings. The mode on the variable OS, we would refer to that as the modal category. The mode on the variable OS is 1. The mode on the variable more descriptively, and you should do this in terms of describing data, is use the name of the category. The modal operating system in this class is OS X, numbered 1. So it's a nice description of an ordinary value on that variable. You can use the mode though for ordinal scales. Have an ordinal scale here, which is freshman, sophomore, junior, and senior. So, in this particular case, if you'll notice, on rank, I just went 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2. In order, so it just ran out at 10. So this is nice. Also, this thing has a mode that is, this is two different values. So freshman and sophomore, excuse me, freshman and sophomore occur one more time than do seniors and juniors. So it doesn't have a single mode. It has two. And it's a nice illustration of when not to use the mode for an ordinal value. But I can give you one guessing at, because the students here are at Ole Miss, if you're going to make up an ordinal scale, 1, 2, 3, that's Democrat, Independent, Republican. And let's say I looked at the frequency distribution in this class, and there's about 30 of you, so we're going to go like 10, 10, and 20. Let's say, well, that's the frequency that I found if I interviewed or did survey research on the class in here, but I'm probably pretty close there at Ole Miss. The modal category here, the category with the most observations, is Republican. And descriptively, the way that you would say that is the modal student in the class is a Republican identifier. Nonetheless, with ordinal, so it was with the mode, you describe central tendency of nominal and some ordinal level scales. I want you to know this too, with respect to ordinal scales though, the more categories that they have, the less necessarily meaningful this can turn out to be. And so if we split partisanship not into 3 categories, but let's say 7, the modal category might be very misleading. It might be sort of an outlier. So just keep this in mind. The fewer the categories in an ordinal level measure, the more likely it is that you might want to describe its central tendency with the mode. More often, though, you'll want to use the mean and the numbers. So, I'm going to go here. This is ratio. Sorry, we'll call that absolute. And work our way back. And talk about test first. It's an ordinal, a ratio level measure. Which should you use? The next video, which is about measures of dispersion, and dispersion really more generally, is actually extremely relevant to the question of whether you should use the mean or the median. Answer relative to the mode should be obvious The answer to the mode should be obvious here. The modal category on test is 71. That's because it alone occurs twice. It's almost exactly the case. So you don't use ever the mean and the median with nominal level measures. You don't use ever the mode, trust me, with ratio level measures. It just so happens that 71 is not too terribly distant from the average here on the test. The mean in those data, and I encourage you to do those yourselves. The mean there is 77.5. I'm going to put that here with test. The median is 77. Pretty close. Either one of those, very nice description of the central tendency or ordinary value. The mode would be a really bad one, off a little bit. Coming back to age, an illustration that relates to the next discussion, dispersion, but I'm going to use it in this context and describe this as an outlier. Look carefully at the list. 18, 19, 20, 21, 18, 19, 20, 21, 18, and suddenly a non-traditional student, 50. This is nice that you got an outlier. An outlier seriously affects the mean as a description of the central tendency or ordinary value. This is because you're using all of the data. Every single observation sums into the mean, and as a result, one outlying observation can lead to a poor description of the ordinary value. When I look here on the variable age, I find that the average is 22.4. Is the mean. Now think of 22.4 as a neat description of the ordinary value. How neat is it? Well, it's awful. Only one person in the class is older than 22.4. In the case where you have outliers, you didn't over here. And when you don't have outliers, you should use all the data, use the mean. In the case where you do have outliers, in this case with age, and are choosing between the mean and the median, you should choose the median. The median here is 19.5. The median doesn't use any of the data really. It only uses order and divides them in half. So that is the clear circumstance with an outlier, and we'll talk about the distribution that would drive you to do that next time. With an outlier on ratio, use the median. Without an outlier, use the mean. Pardon me. It's the chalk dust. Last one we're going to do is gender. Gender is a binary indicator, or binary variable, a dichotomous. Everyone has a very neat, as we'll see next time, with respect to dispersion, a neat outcome. The mean here and the median are the same thing, really. Half of them are above the midpoint, which you would call 0.5 here. But the thing that you always use, always, with a binary variable, always use the mean, x bar equal 0.5. It turns out, we'll see, that x bar equal 0.5, this is a proportion. Obviously, it's a proportion. It's also, all proportions are probabilities. And because of a neat little trick, it turns out these things are easy to manage in the context of the next talk, which is the dispersion. So here, in this video, we've talked about how to characterize an ordinary value on a variable, and talked about 3 different statistics that allow you to do that. And we've talked about when you would use one and not the other across the different kinds of levels of measurements. And that's what I want you to know here. When do you use which one of these to make a sort of descriptive account of an ordinary value on a variable? This is intimately related, this talk, to the next video, which is about dispersion. But that's all for now.